Hello and welcome to lesson 3 of week 4. In this lesson, we're going to look at how to handle errors in Python. My name is Mildred. In Python, we have two types of errors, and we have one called syntax error and the other called logical error or exception. Now, what's the difference between these two types of errors? When we talk about syntax error, is like the way you write your code is wrong. So let's say you're building a house and you place a brick in the wrong spot, right? You already did it wrong, so that's a syntax error. A logical error or exception is something that you have when you wrote your code correctly, but there is something wrong with the logic of the code. For instance, let's say we want to divide something by 0, and we know that we cannot divide anything by 0. We'll get a 0 division error, right? That is an example of a logical error or an exception. Now, there are inbuilt exceptions in Python. We're not going to look at that in this lesson, but we want to look at how to handle error. And when we want to handle errors, we use something we call a try except block. So which means that any code that might result in an error, you want to specify something that you will do if an error occurs, what it will tell the user. I don't want to write a code where my users will see some cryptic message and code that they can't read. For instance, when I say, let's use an ATM card for instance, and you go to the ATM machine and you want to take out money, and you can only take out what you have in your account. You can't take out more than what you have in your account. Also, maybe there is a limit for each transaction for the ATM. We write a try block using try like this, and then we write all the code that might fail. I'll use pass to just hold this so that we don't have an error while we illustrate this, and then we'll say except, and this will have everything you want to do when the code in the try block fails. If you want to print out something regardless of what is happening in the try and except block, you use finally like this. Everything you write in the finally block will execute regardless of the outcome of all the things within the try and except. Now, when we say pass here is you have an error. So when you want to have a block of code but you've not decided what you want to do in those blocks, you can use pass in Python as a statement so you don't have errors. Now let's use the same ATM machine example. Let's say we want to get an input from the user, so the user will punch how much they want to withdraw. In Python, we use the input function to collect information from a user, right? And in the parentheses of this input function, we write the message the user will see. So let's say we have a variable called user input, or let's call it amount. An amount is equal to, we use the input function and say the user should enter an amount. Now, when the user enters an amount, you want to do something with this amount. Now, when you use this function in Python, whatever is returned is a string. The return type of this function is a string when we see it here, str. You want it to be an integer. You can allow it to be a float if you want to give cents and coins or something. So you want the decimals there. But let's say we're dealing with an integer. So you want the amount to be an int. And we looked at casting in the previous lesson, where if they enter the amount and you don't know in advance what users will do, you want to be able to handle all situations. Some user will just want to try the system, break the system. And so you have to prepare for this event. And we use the conditional statement we just learned, that if the amount that is entered is greater than 1000. So if I do this, if amount greater than 1000, I'm going to have an error. And the reason I will have an error is I'm comparing a string and an integer, and it's not going to work out. So we have to cast this to an integer. And so you use the int like this to cast this to an integer. So because the amount is a string, but is a whole number but is quoted, we want to say if the amount that is entered by the user is greater than 1000. So let's say 1000 is the limit. We want to tell them something. We say print, you must enter an amount not greater than 1000. And if not, we'll put else. Let's say we want to say print, take your cash. So this is just like a skeletal example. What if something happens here? What do we want to do? If the amount is greater than 1000, we want to tell the user to enter an amount not greater than 1000. And if the amount is not greater than 1000, we want to say take your cash. In the except block, we want to accept an error. Now, one of the inbuilt exception in Python is the value error, because we're talking about value here. The value is greater or less than, or the input is invalid. So let's say they enter a string now. So now they enter 1000, but the 1000 comes as a string because it's an input function. But let's say the person enters their name instead of numbers. You want to have an error. There's an error that will definitely occur, and you want to prepare for that error. The inbuilt exception in Python has a whole list of different exceptions that happen for different things. Value error is one error that can happen. So you can specify inbuilt errors here that you want to handle, or you can just not specify a particular error so that it will tell you what error it is. So let's say value error let's give it a name E, and when it has a value error, we want it to just tell the user what the error is in plain English, and we say invalid input and say please enter a number. And then regardless of what happens, you want to tell them have a nice day. Maybe they they just take their card out. So I want to print thank you for banking with us. So let's run this. It asks me to enter an amount. I will enter 1,000 and then enter, and it says take your cash, thank you for banking with us. If I run this again, I enter 2,000 and enter. It says you must enter an amount not greater than 1,000, thank you for banking with us. So in the finally block, this is printed regardless of what happens. But let's say I run this and I enter my name instead of an amount. It would say invalid input, please enter a number between 1 to 1,000. So the error is handled here. So if I did not do this in the try except block, what happens is that the user will get a cryptic error saying have value error or something that they cannot understand. So you want your error or whatever is displayed to the user to be something that the user can interpret. If you don't know what kind of error it is, you can just say except print invalid inputs like this. So we're trying to handle errors that are defined inbuilt error. So you can put the inbuilt error here, use has to just give it an alias. Or let me show you something else that you can do. So you can decide to print E. So let me put F here, and I want to print E to tell me the type of error, so that you see what the user would have gotten if you did not put this text here. So I'll run again and I'll enter my name here, enter, and now we said invalid literal for int with base 10. So this is what is going to show the user if you did not handle the error, because we say we want to know what the value error is. Invalid literal for int with base 10. There are different errors that can happen, and you can list all the types of errors that can happen here, or you can just leave it blank to be like a catch-all for any type of error that comes in. But we'll look at exceptions later on, the inbuilt exceptions in Python and how you use them. So we'll look at object-oriented programming first and then come back to look at the exceptions. But this is how we handle errors. In the try block, you write all your code. In the except block, you write what you want to happen or the message to display if an error happens in the try block. In the finally block, which is optional, you write what you want to happen regardless of whatever happens within the try and the except. In the conditional statement or in the if statement, we can raise errors. You see something like you are raising an exception. And let me show you how to do this. Let's delete this. And so let's say we'll not use a try block here. We just want to raise an exception. So I'll say amount is equal to input enter an amount, right? We put a space, and then if int amount is greater than 1,000, we want to say print you must enter an amount not greater than 1,000. So instead of print, maybe we want to use raise. If it's greater than 1,000, we want to raise an error or raise an exception. So let me remove this print and I'll show you. This is not the best example, but I just want to show you how we use the raise exception. So we use raise, and let's put an inbuilt exception type in Python, and we want it to say the maximum withdrawal amount is 1,000. So something like this, and then else take your cash. So I'm trying to handle error within a conditional statement rather than using the try except block. So we'll use the raise statement to raise an exception, and we know the exception type that we want to raise, and we have this inbuilt exception, the value error, and then we use this to say the maximum withdrawal amount is 1,000. You want to look at the different inbuilt exceptions and when they occur, what kind of mistakes you will make before those exceptions occur. So let's use this and see what it prints out. This is not the best example again, we're just trying to illustrate how we can use this between an if else statement. So enter an amount, so enter 1,001, and it says gives me the whole error, and then it raise value error, the maximum withdrawal amount is 1,000, and you write it here, value error, the maximum withdrawal amount is 1,000, because I asked it to raise value error like that. So let me delete this. We can see how it raises this here, right, to raise the error. So let's run again and use a value that is not greater than 1,000. So let's say 1,000 and enter to say take your cash. So this is how we can raise an error, and there are applications of this we'll see when we go to an advanced course and we begin to build our software, and then we'll see when we want to raise an exception versus when we want to handle an error. So this is where we end this lesson. Thank you and see you next week.